Now let's look at the log and the method that does work for shale oil play. So the tool is NMR, and this is a unique tool because it measures porosity independent of lithology, which is different from most of the wireline log porosities like neutron porosity, density porosity, or sonic porosity. These, on contrary, are more sensitive to lithology than to reservoir fluids, well, with the exception of gas-bearing formations. NMR additionally is also useful for its ability to detect the pore fluid types. Now, fluids can occur as bound fluid, irreducible or capillary bound fluid, and free fluid. The two fluid types, which would be hydrocarbon and water, can occur in any of these three forms. And based on your T2 signal distribution, you could essentially say what kind of fluids you have and where they are in the spectrum of your pore continuum. Now, before we get further into the interpretation part, let's delve deep into the workings of NMR. NMR works by manipulating the hydrogen proton contained in water or hydrocarbons. These protons are first exposed to a large external magnetic field, a static magnetic field, which makes the orientation of the protons or nucleus to align themselves with the direction of the external magnetic field, in the z direction in this case. Then a perpendicular magnetic field, which would be a radio frequency, is applied. This new field tips the nucleus away from the static magnetic field direction. This field is applied as a series of short pulses. The interaction of the two fields causes the nucleus to develop a precession motion, which would essentially be in the xy plane. Then the radio frequency magnetic field is turned off, and the nucleus relaxes back to the equilibrium and aligns itself with the original static magnetic field. Now, the time taken for the protons to polarize in this static magnetic field is called the polarizing time, T1, also known as longitudinal or spin lattice relaxation. T1 is essentially time required for nuclei to reach equilibrium in the z direction. After the pulsed magnetic field is turned off, there is exponential decrease in protons' magnetization in the xy plane. This signal is known as the T2 relaxation, transverse or spin-spin relaxation time. T1 and T2 combined together can be used to infer the pore fluid type, water or oil, contained in the major pore systems, which was first observed by Ozan in his work in 2011. I think it is important to state that the instrument measures or detects signal only if hydrogen nuclei relaxes slow enough, i.e. to be detectable. The hydrogen nuclei residing in the mineral matrix generally relaxes too fast to be detected by the instruments. So is the case with the kerogen. Thus, for the NMR measurements, the potential sources of hydrogen include water and oil in the pore space, clay-bound water, and bitumen. So let's come back to the interpretation section. Realistically speaking, the signals aren't so clean looking. The response of the typical shale play would be more like this that you see in this slide. There are overlaps, signals are overriding. So with the T2 distribution, you can separate producible hydrocarbons from other fluids. However, the distribution of these fluids, like I said, have overlaps, and therefore it is hard to directly find the cutoff from T2 distribution to separate producible hydrocarbons or oil from other fluids. Well, knowing these limitations as well as its potential, which we already talked in previous slides, let's now look into the method that uses this and other logs to delineate the producible hydrocarbons or pay intervals from other non-pay or immovable bitumen in the shale oil plays.